Hello everyone. This video is on the Newton Alta assignment for section 3.4 part 1 called Triangles and the Pythagorean Theorem. Alright, in this video I'm going to be going over a preview version of this assignment. Pardon me. So please understand that the questions I see in this video may not be the same questions that you see when you work on the assignment yourself. But the objectives are all the same, the structure is similar, so I'm hoping that watching me do these here will help you in some way when you work on the assignment on your own. Alright, so on your assignment page, you should be seeing the title, the mastery bar that tells you how far along you've gotten, the objectives. Looks like there are 3 objectives for this assignment. Under the current objective, right, there is a question related to that objective, and at the bottom of each question you should be seeing a feedback button for which you can send feedback to Knewton if you wish. You will not have this instructor cheat button. This is for instructors only. But you will see a more instruction button. If you're struggling with a topic, click on this. It'll take you to a page with some reading or some videos to study, and you'll be given questions related to that instruction, and completing those questions will make you progress through the assignment. Alright. So the first objective I'm looking at here is solve triangle problems where angles or sides are given in terms of other angles or sides. Okay. Alright, so I'll read this question and then I'll say a few things about it. Some things you need to know about particular words, like the word perimeter. So we have here the perimeter of a triangle is 49 feet. One side of the triangle is 17 feet shorter than the second side. The third side is 6 feet shorter than the second side. Find the length of each side. Alright, so I'll do that thing where I leave hopefully you can read the problem. And I'll just draw a triangle, a very generic triangle. Alright, it's a 3-sided polygon, right, 3-sided figure. And just remember perimeter. The perimeter just means the sum of the lengths of the sides, going around the figure. So it's just the sum of the lengths of all the sides, so the 3 sides. And they told us the perimeter is 49 feet. Right, so it's 49 feet around. If you add up all 3 sides, it should be 49. Now this, let's say I call this the first side over here, the second side here, and the third side. Alright, and they tell us that one side, I'll call that the first side. The first side of the triangle is 17 feet shorter than the second side. So say the second side is x feet long. It's just like any word problem. You have an unknown like the length of this second side and you call it something. Name it. I'm naming it x. And they say the first side is 17 feet shorter than the second side. So take the second side, x feet, and then subtract 17. And that'll be the length of the first side. Alright, so one side has a length of x minus 17. The second side has a length of x. And then the third side, they say, is 6 feet shorter than the second side again. So I take the second side length again, x, and then subtract 6. Right, it's 6 feet shorter. And that's all we need. Alright, so I'm going to go just make the page a little bigger. And here's our equation. Right, we're going to translate into a mathematical equation, solve that equation, and answer their questions. Alright, so again, the perimeter is just the sum of all the side lengths. So the first side, right, is x minus 17 plus the second side we just called x feet plus the third side, right, is this x minus 6. Now I don't really need the parentheses here because these side lengths aren't being multiplied by anything, so I'll ignore those. And then this should be equal to 49 feet, right? They said this was 49 foot perimeter. Simplifying the left side here, I have x plus x plus x, that's 3x. Then we have a negative 17 plus negative 6, that'd be minus 23, equals 49. And let's solve this equation for x, right? And you again use the solution to answer the question, right? They want all three side lengths. So adding 23 to both sides, 49 plus 23 would be 72. And then dividing both sides by 3, x equals 24. All right. X equals 24. 3 times 24 is 72. And then I just pop those in. Right? So that x, remember x represented the length of the second side. So this is 24 feet. And they said the first side was 17 feet shorter than that. So 24 minus 17 would just be 7 feet. And the third side was only 6 feet shorter. 24 minus 6 would be 18 feet. Alright. And if you add these up, 7 plus 24 is 31, plus 18 is 49, right? It matches the perimeter that they gave us. So 7, 24, 18 are the numbers I'm going to put in. They already have the word feet afterwards, so I don't need to put that. So the first side, 7, second side, 24, third side, 18, and that should be good. And then after you submit an answer, it'll tell you whether you're right or wrong, and then give you some sort of answer explanation. Please read through these answer explanations just to make sure you understand why something was correct or incorrect, and hopefully you can learn from your mistakes for future questions. Alright, next. Okay, so here we're in the objective, solve triangle problems using the Pythagorean Theorem. Alright, so I will state the Pythagorean Theorem first, and use the Pythagorean Theorem to find the length of the leg in the triangle shown below. Alright. Now the Pythagorean Theorem only applies to right triangles, triangles with a 90-degree angle in it. So in a right triangle, and a right triangle only. Alright, so something that looks like this. A triangle with a 90-degree angle in it, or a right angle in it. This is a right triangle. Now, in a right triangle, the lengths of the sides have certain names. The two sides that form the right angle, so this side here and this side here, are called the legs. Alright, so maybe I'll call this, leg 1 and leg 2. And then the longest side, the side opposite the 90-degree angle, is called the hypotenuse. Okay, it's called the hypotenuse. So in a right triangle, if you take one leg length and square it, and you add to it the square of the other leg, so leg 2 squared, that will be equivalent to the length of the hypotenuse, that longest side opposite the right angle, squared. All right. And you may have seen this as a squared plus b squared equals c squared. You know, if you call the legs a and b units, and you call the hypotenuse c units, it's a squared plus b squared equals c squared. But it's the sum of the squares of the legs is equal to the square of the hypotenuse. So the picture they're giving us in this problem here looks like this. You have a right triangle. The length of the hypotenuse is 15 units long. The length of this vertical leg is 12 units long. We just need to find the length of this leg here, this horizontal leg. So I'm going to call this x units long, right? If I don't know it, so I'll name it something. And then by the Pythagorean theorem, x squared plus 12 squared, right, the sum of the squares of the legs should be equal to the square of the longest side, you know, that side opposite the right angle, the square of the hypotenuse, right, 15 squared. And now we have an equation that we can solve for x. So here we have x squared plus, 12 squared is 144 equals 15 squared is 225. And then I subtract 144. We'd have x squared equals 81, right? 225 minus 144. So x can be either positive 9 or negative 9, but remember we're talking about lengths of sides of triangles, which, they should be positive. Right? Lengths of sides of a figure in 2D space should be positive quantities. So I'm going to ignore the negative 9 and say x has to be 9. This other side has to be 9 units long. And then you can double check that, say 9 squared is 81, 12 squared is 144, and then 81 plus 144 is 225, is 15 squared. The sum of the squares of the legs equals the square of the hypotenuse in this right triangle. It satisfies the Pythagorean theorem. And all we're asked to do is enter the number. What's the length of that missing leg? It's 9 units long. Great. All right, next question. All right, so this one, and the other objective we haven't seen, solve problems involving the perimeter, area, and interior angles of triangles. All right. So this one's about the area. All right, so we'll talk about the formula for the area of a triangle. So a triangular road sign has a base of 30 inches and a height of 40 inches. What is the area? Now, area is in square units, square feet, square inches. You see how they have the word square inches written here? We just have to put the number for the area. But area is in square units. All right, so the area of a triangle, and I'll just write the problem up here. So again, here's just some generic triangle. It doesn't have to be, it's just any triangle. You pick a side, I'll pick this side that's flat to us, horizontal to us. Call that the base. All right, so this side here, this horizontal side, I called the base. And then the height of the triangle is the distance from the opposite vertex to the base. So this vertex opposite the base, if you were to draw a perpendicular segment, which I'll make like a dashed line here, that's perpendicular, forms a 90-degree angle with the base. This distance here is called the height of the triangle. Alright, so you pick a side to be the base, and then the distance from the opposite vertex to that base, right, if you go straight perpendicular to it, that's called the height. Alright, and the area of a triangle is 1/2 the product of the base and the height. Okay, so it's the base times the height, but then you cut that in half. That's it. That's all you need to remember. Right? Area is a pretty quick formula for a triangle. Now they told us, in our example, the problem they gave us, they said the base, a base of the triangle is 30 inches, and the height of the triangle is 40 inches. What's the area? I'll just use A for area. Well, the area then would be half of 30 times 40. And that would, of course, be inches times inches. So square inches, you might see inches squared like that, or square inches as they've written out in words. And this is 600. 600 square inches. Right, because 30 times 40 is 1200, and then cut that in half. And that's all they want, and we're just going to fill in the number 600. Right, because they already have the words square inches written out. Wonderful. All right. Alright, so again, same objective as the last question, but this time we have a problem involving the interior angles of a triangle. So we see here one angle of a right triangle measures 36.5 degrees, 36.5 degrees. What is the measure of the other small angle? Alright, so once again I'll make a little statement here about the angles of a triangle. So here's some generic triangle, just a three-sided figure. And say this is angle A, this is angle B, and this here is angle C, or angle 1, 2, and 3, whatever you want to call them, as long as you know they're different. The measure of angle A plus the measure of angle B, that's what this little M means. It means measure of, and then this symbol here, the little angle symbol, means angle. So the measure of angle A plus the measure of angle B plus the measure of angle C will be equal to 180 degrees. Right, and this is the case for any triangle. Right, any triangle on a plane, right, in a two-dimensional space. The sum of the interior angles, or the angles formed inside the triangle, the sum of the interior angles will always be 180 degrees exactly. So in the question they gave us, right, they said that one angle of a right triangle. So we are given a right triangle. So that means this angle is 90 degrees. And they said one of the other angles is 36.5 degrees. What's this other one? Which I'll call x degrees, right, or just x. And use the fact that I mentioned a second ago, that the sum of all three interior angles of a triangle must be 180, right? So x plus 36.5 plus 90 must be equal to 180, right? And you just know that those are all degrees units. Well, 36.5 plus 90 is 126.5. And then I'm just subtracting 126.5 from 180, which would be 53.5. Right, so this is a 53.5 degree angle. And you can add them up. 53.5 plus 36.5 is 90, and then plus another 90 would be the 180. Right, so this is what they want. Now they already have the degree symbol in there. Right, you don't have to put the degree symbol. See the little tiny degree symbol after the box. We're just putting the number 53.5. Great. Okay. Alright, so back to the Pythagorean Theorem. Alright, so they give us a little picture here, but we just have to, I'll just draw this right triangle up. We're saying, it says Brian borrowed a 20-foot extension ladder to use when he paints his house. If he sets the base of the ladder 6 feet from the house, as shown, so you see the bottom of the ladder is 6 feet from the wall. The ladder is 20 feet long. How far will the top of the ladder reach, right? So how far up the wall is the top of the ladder? And we're asked to round to 1 decimal place, right? So I might have to use a calculator here and then round. But here's the picture. So again, we have this right triangle, right, where the ladder is 20 feet. Let's say this is the house here, and this is the wall, and we have a right angle. Right? We're assuming that the wall of this house and the ground form a 90-degree angle, right? And the bottom of the ladder here is 6 feet away from the house. They're asking you the length of this other side. I'll call it x. Right? How high up the wall is the top of the ladder going? So this is a right triangle, right? So by the Pythagorean theorem, x squared, right? One leg squared plus the other leg squared, right? X squared plus 6 squared equals, and then the hypotenuse, which would be the length of the ladder, 20 squared. So x squared plus 36 equals 400. Alright, then I subtract 36 from both sides. X squared equals 364. Alright, and then I take the square root of both sides. So x equals the square root of 364, which we're asked to round to 1 decimal place. Now again, it could also be negative, but we're talking about a length here, so I'm just going to ignore negatives for lengths. And then I'm just going to go to that Desmos calculator, right? A free online graphing calculator, punch in square root of 364, and that's 19.07. So rounded to 1 decimal place, that'd be 19.1, about 19.1 feet. So 19.1 feet up the wall. Wonderful. Okay, now I don't know why they have this picture with 17 and 8, and then they use 20 and 6 down here, so maybe you'll want to leave some feedback about the picture being wrong, but the calculations are correct. They use 20 and 6, but the picture is off. Okay. Alright, so back to this one. Alright, so here the angles in a triangle are such that one angle is 78 degrees more than the smallest angle, while the third angle is 4 times as large as the smallest angle. Find the measure of all 3 angles. Alright, so once again, I'll just draw a picture. I'm not going to leave the problem up this time. I'll just read it out loud again. So again, we have a triangle. Now, you don't have to draw a picture of a triangle every time, but... So let's say this is the smallest angle here. Just saying. Alright, just call one of these the smallest angle. And you may have noticed, they describe the other two angles in terms of the smallest angle. So I'm going to call the smallest angle x degrees. Right, say that's x degrees. And then they said one angle, let's say this one here, was 78 degrees more than the smallest angle. So this is x plus 78. This is x degrees. This one's x plus 78 degrees. And then that third angle, they said, is 4 times as large as the smallest angle. Right? So 4 times x degrees. And we're asked to find the measures of all 3 of these angles. Now this is coming back to that one fact about triangles on the plane that I mentioned. That again, the sum of all 3 of these interior angles should be 180 degrees, right? So x plus 78 plus 4x, right, should be equal to 180. Right? And then we solve for x and use that solution to figure out the measures of all 3 of these angles. Now I have x plus 4x, that is 6x. And then the only constant term on the left side is plus 78 equals 180. Then I would subtract 78 from both sides. We'd have 6x equals 102. And then divide both sides by 6. Right, so x equals 17. Right? 6 times 17 would be 102. So the smallest angle is 17 degrees. Right? That's what x represented. Add 78 to this, right? 17 plus 78 would be 95 degrees for this second angle here. And then 4 times 17 is 40 plus 28, that's 68 degrees. So we have a 17 degree angle, a 95 degree angle, and a 68 degree angle. All right, and then let's just add them up to make absolutely certain that we have 180 degrees here. Right. So 17 plus 68 would be 70. 85 plus 95 is 180. So this checks out. So these are the numbers I'm entering. Now they already have the degree symbol, right? So I don't need to enter the degree symbol. I just need to enter the numbers. So yeah, we have a 17 degree angle. Then we had a 95 degree angle and a 68 degree angle. Great. All right, next question. All right, so this one is about area. I'm noticing square meters here, right? That's an area unit, square units, square meters. They're asking here, what is the height of a triangle with an area of 67.5 square meters and a base of 9 meters? So you're just going to that area formula for a triangle. I'll write that up again. Right, the area of a triangle was half, the length of a base times the height. Or you can put BH for base height. Now they told us the area. The area is 67.5 square meters. So I'm putting that in for A. They also told us the base is 9 meters. We just need the height. I'll just call it H for height. So I mean half times 9 is 9 halves. same thing, times h. And all I need to do now, is multiply both sides by 2/9. And just multiply both sides by 2/9. So I have h equals, now 2 times 67.5 would be 135. But then we're dividing this by 9, right? We have a denominator of 9. And, 9 goes into 13. This is 15. All right, 9 times 15 is 135. And don't forget, this is meters. Right? Lengths are in single units, meters. Area is in square units, right? So the height should just be 15 meters. And they already have the word meters written out. 15. I'm just entering the number for the height. Great. Alright, next. Alright, so another one where they give us the area and the base of the triangle. We want the height again. Right? So it's very, very similar problem. So I'll just throw this under here. So they told us here the area is 893 square inches. That's replacing the A. Equals half of the base, and the base is 38 inches times the height, right? And again, h for the height. We just want to find the height. Now, half of 38 is 19. Right, so this is just 19h, and to get h alone, I would just have to divide by 19. Right, so h equals 893 divided by 19. Let's see. Now 4 times 19 is 40, and 36, that's 86. Just gotta do a calculator here. I'm probably making this more difficult than it needs to be, but 893 divided by 19 is a nice even 47. And there we go. And this should be in inches, right? They said the area was in square inches, the base was in inches, so the height should also be in inches. Alright. So 47. Wonderful. Alright, so that objective's finished. Let's continue on. Alright, so another problem about the angles, right? And just remember that the sum of all three interior angles of a triangle on the plane should be 180 degrees. So the angles in a triangle are such that one angle is 100 degrees more than the smallest angle, while the third angle is 2 times as large as the smallest angle. Find the measures of all three. So very similar to a problem we saw a little bit ago. Alright, so this time I'm just going to say, hey, let's say the smallest angle, let's call that, I'll call it x again, and then, another angle, right, they said was 100 degrees more than the smallest angle, so x plus 100, and then the third angle was, 2 times as large as the smallest angle, so 2 times x. And these are angles of a triangle, so they should add up to 180. Now if I add these up, x plus 2x, that'd be 4x plus, and then you got the plus 100. This should be equal to 180, right? This is their sum right here, 4x plus 100. And this should add up to 180. Subtracting 100 from both sides, I have 4x equals 80. Dividing by 4, x equals 20. So that's the smallest angle, 20 degrees. Then, plus 100 would be 120. and then times 2 would be 40. Right, so the angle measures are 20, 120, and 40. Those add up to 180 degrees and fit their description. So the smallest angle was 20 degrees, and you don't have to put them in any particular order. The next one with 100 more was 120 degrees, and then double the smallest was 40 degrees. And there's the angle measures they're asking for. Okay. Alright, so one more of these. Now this one's about perimeter. Alright, so not the angles. Remember, perimeter is just the sum of the three sides. Right? And the sum of the three sides should be 53 feet. It says here one side is 12 feet shorter than the second side, and the third side is 4 feet shorter than the second side. Find the length of each side. Alright, so let's do this on paper again. Let's do this here. On this other, there's a lot of space over here. So I'll go here's first side, second side, third side. These are my unknowns. And I'll give them names, right, with expressions. Now they put the first side and the third side in terms of the second side, so I'm going to call the second side x. And they tell us that, you know, the one side is 12 feet shorter than the second side, so that'd be x minus 12. And the third side is 4 feet shorter than the second side, so the second side minus 4. And then let's take their sum. If I add all these up, I'll have 3x and then minus 16. Right? Minus 12 plus minus 4 is minus 16. And this should be equal to 53, right? This was the perimeter. Right? They told us the perimeter was 53 feet. And then I solve for x here, and we can find the lengths of these sides. So first I'll add 16. That'll be 69. Then dividing by 3 gives me 23 for x. So one side has a length of 23 feet. And then 23 minus 12 would be 11. And then 23 minus 4 is 19. And there are the three side lengths that were asked for. Right? And double check, add these up, you do get 53 feet total, right, for the perimeter. So 11, 23, and 19. 11 feet, 23 feet, 19 feet. Alright, so that objective's done, and then the last problem should be on the Pythagorean Theorem. And that's the only objective we haven't completed yet. Alright, so we have this picture. Chi is planning to put a path of paving stones through her flower garden, as shown below. So you see the path of stones that cut across this rectangle. The flower garden is a square with a side. Oh, it's actually a square, not a square is a rectangle, right? But not every rectangle is a square. Now, a square means every side has the same length. So the horizontal side on the bottom here is 10 feet. Every side around this is 10 feet. We're asked to find the length of the path of stones, right? What's the length of this path going diagonally across the square? And round your answer to 2 decimal places. So once again, I'm probably going to have to use a calculator here at the end. Alright, so here's the picture. Now, I'm just going to put the right triangle up. You know, we got 10 feet here, 10 feet here. There's the right angle. Right, it's the corner of a square. And then the path of the stones forms the hypotenuse. And we don't know what that is, so I'll call it x. Alright, so by the Pythagorean theorem, you know, 10 squared plus 10 squared will be equal to x squared, right? The sum of the squares of the legs will be equal to the square of the hypotenuse. So this side is just 200 equals x squared. So x, the length of this side, is going to be the square root of 200, whatever that is. And we're asked to round to 2 decimal places. Right, so I'm going to go to the Desmos calculator, and then instead of square root of 364, I just change that to the square root of 200, and it's 14.142. So rounding to 2 decimal places, I'd keep that 14.14. So the length of the path there across that square is approximately 14.14 feet. Wonderful. Alright, I should have, based on my progress, I should have just one more of these. Once again, I do not understand why they're doing this. See, the picture doesn't match the calculations. So again, maybe you'd want to send some feedback, or I'll do that too. Say, hey, you know, maybe you want to have your pictures match your actual numbers here. But the calculation's correct, you know, at the bottom. Alright, and one more, and this is just the one where they don't even give you a they don't give you like a fancy picture of a garden or a house or anything, but it's just a picture of a right triangle, like the first example with the Pythagorean theorem we saw, and we're just simply asked to find the missing length here, which is a leg, right? One of the sides that forms the 90-degree angle, one of the legs. Alright, so I'll just do this on the same page. We have this picture given to us, this right triangle here, where the one leg, the vertical leg is 20 units long, the hypotenuse is 25 units long, and we want to find the horizontal leg. Now again, by the Pythagorean theorem, since we're dealing with a right triangle, I can apply the Pythagorean theorem. X squared plus 20 squared should be equal to 25 squared. Right, the sum of the squares of the legs equals the square of the hypotenuse. Okay, so we have x squared plus 400 equals 25 squared is 625. Subtracting 400, we get x squared equals 225. And then, you know, again, you could be plus or minus, but we're going to ignore the minus because we're talking about lengths. The square root of 225 is 15. This is a nice whole number, actually. So the length of that missing leg, that missing side, is 15 units long. It's got to be. And all I'm asked to do is put in the number, right? There's no units on these, just 15. Wonderful. Alright, and that should be it for this preview version of this assignment. Now, like I said at the top of the video, please understand that the questions I saw here are not going to be the same questions you see when you do the assignment yourself. But the objectives are the same. Right? The structure should be similar. So I'm hoping that seeing me do these here helps you in some way when you work on your assignment on your own. And thank you very much for watching.